This is an RNZ podcast.
Super scientist Nanogirl is on a mission to show everyone the wonders of science. She's joined by her trusty sidekick, the constantly learning artificial intelligence repository. We call her Claire. Let's cross now to Nanogirl's secret lab.
Claire, can you bring up the list of films that I have saved in the library, please?
There's a lot of them, Nanogirl. Is there a particular type that you feel like watching?
What do I feel like? Oh, space. Do I have any space films?
You have exactly 97, Nanogirl, 3 times more than any other type.
That's because I do love space. It's such a fun place for science-based adventures. Let's go with the classic, Star Wars.
I calculate that this is the 13th time you have watched Star Wars.
Oh, but space is just so exciting. It's this wonderful, uncharted territory, and the lightsabers are so cool.
Careful, Nanogirl, you'll put the lightsaber through the TV again.
Oops.
Perhaps while I'm loading the movie, you can look into Ava's question about space.
Great idea, Claire.
Do you know what would happen if a person got sucked into a black hole?
That's a tough one. I mean, it's not like we could visit a black hole to find out. We might never get back with the answer.
Is there any other way to help Ava then?
I reckon I can. And my friend David knows a ton about space and black holes, so maybe we just need to visit him and we'd have a better idea. It's off to Christchurch for this one, I think, Claire. To the jet vault. It's such a stunning day to be flying down country. Oh, there's Taranaki Monga. And, oh, there it is. Look at the Kaikoura Ranges. We must almost be there now. I love flying. Now, what school was I visiting again? Oh, I can't remember. Oh, but look, there's a school. I might just land here and see who's in there. Here we go. Oh, that was a really good landing. It's nice and flat here, wherever I am. Hold on a second, here's a door.
Hello.
Hi, how are you? I've just landed and I just wondered where I am.
Cobham Intermediate.
Cobham Intermediate, perfect! My GPS was on track. I'm in the right place. I'm looking for somebody called Ava.
That's me.
Oh, Ava, hey! I'm Nanogirl and you sent me a fantastic question and I wondered if you could tell me what it was again.
Yeah. Do you know what would happen if a person got sucked into a black hole?
Whoa, a person got sucked into a black hole. I don't even know if that's happened to anybody before. Do you know if that's happened to anybody before?
No, hopefully not. Well, if it did, they probably wouldn't be here to tell us.
Oh, that's not helpful. What do you think might happen if you get sucked into a black hole?
You would die.
Probably, stretched out and then, collapse.
Stretched out and collapse? That doesn't sound very pleasant.
No, not a whole lot. I think you'll just probably disappear.
Disappear? What do you think?
My hypothesis would probably be that you would lose all your oxygen.
Oh, that's also not helpful, is
Like
it?
teleport as well. Go into
Teleport.
another dimension.
You could, go through it and then in the end, pop off in the alternate universe.
I like these theories. However, I actually don't know the answer, Ava. But I have a friend who does. His name is David. Should we go find him and see if he can tell us the answer?
Yeah. Yes.
Okay. Do you want to go in the jet vault?
Yes.
Okay, everybody,
Yeah, sure.
come on in. Right, squeeze in. Seatbelts on.
Oh, stop putting your elbow up my nose.
I know, it's pretty small in here, sorry.
Ow!
Okay, this is going to go pretty fast. We're going to go straight up. Ready? 3, 2, 1. That's okay, we're up. Okay, now look how tiny your school looks down there.
Looks like a little ant.
Oh, and there's snow on the mountains. Okay, I think we're in the right place. It's time for the only landing that I know, which is a crash landing. So don't worry. Just hold on. Ready? 3, 2, 1. Is everybody okay?
No, I think my heart just jumped down to my throat, grew legs, and ran away.
Oh, is it back in there? You're still breathing. You'll be fine. All right, everybody out of the jet vault. I can see him. There he is over there. There's David. Hi, David.
You nailed that landing, Nanogirl.
Rare.
Welcome to the University of Canterbury here in Christchurch. I'm David Wiltshire, and I'm a professor of theoretical physics working in cosmology.
That is perfect, because Ava had a question. What was your question, Ava?
Do you know what would happen if a person got sucked into a black hole?
Well, I can imagine what would happen, and we have seen things fall into black holes, because there is a huge one in the middle of our galaxy, and about 12 years ago something like an asteroid fell in, and it sort of gave off a little burp of ultraviolet radiation.
A burp?
Ew. Yuck.
Did it smell like a burp?
Fortunately, we're so far away you can't smell anything.
That's good. I
And
didn't
smell
know.
doesn't travel in space.
Did you know that black holes could burp?
No.
It's gross.
Do we have black holes in our galaxy?
Actually, there's probably millions upon millions of black holes in our galaxy, and most of them are quite small, relatively speaking, like the mass of our sun or 10 solar masses. And we can't see them because the gravity there is so strong that light is bent in. That's why it's called a black hole. But we do have a huge, humongous, supermassive black hole in the middle of our galaxy.
Is supermassive the real size of a black hole?
Yep, that's the technical term. So the one in the middle of our galaxy is 4.5 million times the mass of our sun. 4.5 million solar masses. That's humongous, and we call that supermassive.
How does a black hole form?
Well, one way is that when a star has finished burning up its nuclear fuel, first of all, it will expand and get very large. It goes through different phases, but eventually there'll be a bang. It'll just blast all the stuff off very, very quickly, and what's left will collapse and form a black hole. So when our sun dies, it will become a white dwarf. But if something is bigger than that, then it will form a neutron star. So that's when all the atoms stop existing. It's the nuclear force which is holding it up. But if there is what's left is really, really, really a huge amount, then it will form a black hole. So that's one way. That's a supernova. And then you can also get two black holes getting together and forming a bigger black hole. And we detect those now.
So why don't all the black holes form together and make one massive black hole? And like suck in the whole universe?
Well, most black holes are quite harmless. So you have to, it's all a question of distance and scale. So things have to be very, very close together in order to get together. So you might ask, well, why doesn't the moon fall into the Earth? Or why doesn't the Earth fall into the sun? It's the same business. And it's all to do about orbits and angular momentum.
So if I was in the jet vault and I came across a black hole, I might not be sucked in because of something called angular momentum?
Yes.
What's that?
Well, it goes back to basic laws of physics that if you have a velocity relative to something and the distance from the thing that you're orbiting, then you will keep on orbiting. You won't fall in. So the Earth has angular momentum around the sun. That's why it doesn't fall into the sun. The moon has angular momentum around the Earth, and the satellites and the astronauts sitting up there, they've got angular momentum. They're not falling down. They're all in orbit.
That is very cool.
So do things get sucked into black holes?
Yes, we've seen something falling in, about an asteroid, but a long time ago, when the universe was younger, there was a lot of gas around, and so the black holes in the middle of galaxies were sucking things in all the time, so stuff that was nearby. And when that happens, then you get jets of particles flung off, so not just a burp, but it's fireworks. And so we see active galaxies far away with huge jets of particles being shot out at speeds close to the speed of light, and that's the most energetic things that go on in the universe since the Big Bang, more or less.
So you said that like stars will, when their life ends, they'll become a black hole.
If they're very big.
Yeah.
So our own sun will become a white dwarf.
What's the difference between a white dwarf and a black hole?
A white dwarf is a cold star. We can still see them, so it's still radiating. It won't stop light coming out. So a black hole, to be black, has to be dense enough that nothing can escape, not even light. So anything can be a black hole. If you shrink the Earth down to so that you put all the mass of the Earth in something that was less than a centimetre, that would be a black hole.
So do black holes have a lifespan?
That's a really good question. As far as we know, a black hole will just keep on living forever unless the universe would die in a big crunch, but otherwise a black hole will just get bigger.
So how far away is the black hole in the centre of our universe?
27,000 light years, I believe.
What's a light year?
It's how far light will travel in 1 year.
And how far is that?
So light travels at almost 300,000 kilometres per second. And so if it's 27,000 light years away, that means the black hole in the centre of our galaxy is, let's have a think, 924,750,000 years away.
That's some serious math.
Wow, you would have to be over 924 million years old to get there.
What about with the jet vault?
Even with the jet vault. In fact, it's probably slower with the jet vault, I'll be honest with you. Does anybody think they're going to live long enough to...
No, I don't think many people will.
Unless you're a zombie.
So the stars we see, the thing in the centre of the galaxy we're seeing as it was 27,000 years ago. And we can look even further back, billions and billions of years with huge telescopes. So you're looking back in time when you look out in the universe.
So I can see why it's really hard to do an experiment to see what happens if a person goes into a black hole, because it would take a really long time to get somebody there. And I wouldn't want to volunteer for that, I don't think.
If our nearest black hole is 27,000 light years away, wouldn't that mean that some of the stars in our sky could actually be black holes?
There are many black holes, small garden variety of ones of a few solar masses or 10 solar masses, which are much closer. It could well be the case that there are a few black holes within 100 light years and we just don't know.
Do black holes need to eat things?
They don't, nothing needs to eat. The garden variety black holes are happily spinning around the galaxy just like any other star.
If you're an astronaut going out into space, what if your spaceship suddenly got stuck in a black hole?
Well, I've done a few calculations, and it's all a question of how big is the black hole relative to you. So the common or garden variety of black hole, if you're right on target, so you have to be right on target because it's very easy to get shot off, that one will pull you apart and spaghettify you. So, but
Wait, spaghettify? Is that where you get turned into spaghetti?
Is it even a word?
yes, it is a technical term, spaghettification. That is what happens to you when you fall into a black hole. And
Spaghetti.
if you imagine falling in feet first or head first, or whichever direction is going first, that direction will be stretched and the other one's squished.
So will I taste good?
Well,
How did you figure it out? Like, how did you figure out that people would get made into basically a long string of spaghetti?
this is something we call tidal forces, and you can all work it out if you know enough mathematics. So if you take a black hole which is 10 solar masses, then it would be about as big as Christchurch. And if you go near it to 10,000 kilometres away, the stretching from your head to your feet would only be as it is here on the Earth's surface, 1g. If you then let yourself go with no angular momentum, just go straight in, you'll go in 1 second, and then there'll be 4 billion times the gravitational force left pulling the last little atoms of you apart.
Ow.
That's a lot.
What's at the bottom of a black hole? Like, if you were in a black hole and you got sucked in, would you, like, be left at the bottom, or would you, like, teleport?
Well, if you go and watch the movie Interstellar,
Great movie.
there are wormhole aliens, but I'm coming back. Personally, I don't go with that particular science fiction version of things, but the whole thing is we don't know, and that's why I do my job.
If a black hole's black, how do we know what it looks like?
Well, some of them are not black because they are actively sucking in gas, and those ones we can image, like this. This is the image of plasma and light near a supermassive black hole which is actively eating things.
It looks like a golden donut.
And
I
that
want to
one's-
eat it.
So it's brighter on one side and fainter on the other, and that's because of the light being dragged around one side. We know it's rotating, we can work out that it's rotating, and this one is 6 billion solar masses.
So that's huge.
That's huge. That's super duper, and that's not a real word, but that's more than 1,000 times bigger than the one in the middle of our galaxy. This one's 54 million light years away.
Can two black holes crash into each other?
Yeah, they crash into each other all the time. We've never known in the past how do you make big black holes. Now we can discover gravitational waves, ripples in the fabric of space. We can now detect black holes merging tens of millions of light years away.
If two black holes crash into each other, do they make a cool crashing sound?
Well, the first merging of two black holes was emitted at the time that the dinosaurs were on the Earth, and it took all that time to get here.
What, so we can hear the sound of two black holes crashing?
It's not, because sound doesn't travel in space, but the ripples in space travel in space, and the ripples in space have frequencies, and those frequencies are actually audible. And
what do you think the frequencies sound like of two black holes crashing together?
Very, very loud.
David, can you play us the sound?
So this is called a chirp.
What? Really? Is that really the sound?
That is the real sound. We know now that black holes merge. It's really difficult to measure. It's the most sensitive measurement ever made in human history, because you've got to detect something like the width of the hair at the distance of the sun.
So you said earlier that if you cram something massive into something really tiny with some special machine, would that make a black hole?
Yes, absolutely.
That sounds cool. Shall we work on making a black hole machine?
Yes.
Do you think we could do that, David?
That's the unfortunate thing with astronomy and astrophysics, is that we deal with things that you can't do on Earth because it's the most extreme conditions in the universe.
I think that answers our question. Ava, did that help you answer your question?
Yeah, it did. I know heaps about black holes now.
And we learned how to make spaghetti. Spaghetti? Oh no, that's not right. Spaghettification. Okay.
Spaghetti.
I know. And donuts. This is a very food-related talk today. Thank you so much, David. I'm going to have to get these guys back to school, though, I'm afraid. So,
Oh, really?
thank you, David. It's been amazing. We've learned lots about black holes. Everybody, back into the jackpot.
No, please, no.
Hi, Nanogirl. Were you able to answer Ava's question?
Kind of. We found out that if somebody got sucked into a black hole, they'd probably be spaghettified, which is like when you're flattened and stretched at the same time.
Youch!
Yeah, I can't imagine that it would be any fun. But otherwise, we still really don't know what happens once you've gone into a black hole, well, because nobody's actually done it.
I hope you're not planning on attempting it.
I do a lot for science, Claire, but I won't do that. What I am planning, though, is a great experiment. Let's go to the lab. For this experiment, you're going to need a sharp pencil, a wooden skewer, stiff card, something circular to draw around like a cup, some scissors, a ruler, and if you like, some blue tack. So you're going to place the circular item onto the piece of card, and then you're going to draw around it to make a circle. Now, use the ruler to find the centre of the circle and make a mark so you know where it is. Next, you're going to cut out the circular shape with your scissors. Push your wooden skewer through the centre point of the circle, so it's about 1 centimetre of it is sticking out below, and then secure in place with the blue tack if you need it. Next is the fun part. You're going to twist it with your first finger and your thumb and make it spin. And there you go, you'll see it's spinning. And that's how you make your own spinning top.
To have your own science adventure, check out the video on the RNZ website.
It's got all of the instructions that you're going to need to make your own spinning top.
Have a go and let us know how you get on. You can email us on scienceadventures@rnz.co.nz.
Let's see if there's any popcorn left, Claire.
I'm pretty sure you ate it all, Nanogirl.
Oh, well, we better make some more then.
Why?
Oh, because we've got 97 space adventure movies to watch, Claire, and that's going to need an awful lot of popcorn.
They Thanks for listening to Nanogirl's Great Science Adventures.
And thanks to David Wiltshire from the University of Canterbury, Sam Allen from Copham Intermediate for a really curly question, and his friends Ava Streaker, Jaeger Price, and Hannah Wood for helping us discover more about black holes.
Find all of Nanogirl's Great Science Adventures on any podcasting app. It's on Apple Podcasts, Google Podcasts, Spotify, Podbean, Stitcher, and iHeartRadio too.
It's also on the RNZ and Nanogirl websites. Wherever you find it, remember to click the subscribe button so you don't miss out on an episode.
And rate us too. Then others get to have great science adventures as well.
We'd also love to hear from you. If you have a great question, don't be afraid to ask us. Email scienceadventures@rnz.co.nz.
This podcast was made by Dr. Michelle Dickinson, Sophie Fern, Marie Pipe, Jocelyn Bunch, Crystal Lee Brown, Liz Garton, Tim Watkin, and RNZ's amazing sound engineers.
Until our next adventure,
Ka kite
Kakitiano!
anō.